My name is Greg Williams. I'm a lecturer in the Computer Science Department at the University of Colorado, Colorado Springs. I'm also, among other things, the Director of Networks and Infrastructure for the IT department here at the university. This course is Linux System Management and Security. So I'm going to be covering the practical side of Linux system management and security. I've been doing this for around 15 years, ever since Red Hat actually first came out. I'm not a certified Linux professional or a certified Red Hat engineer or system administrator, but I manage Linux systems all the time. And I know a little bit about what Linux does and how we manage Linux systems practically. There's the theoretical side and there's also the practical side. And a lot of what we hear when we're doing system management is the theoretical side that you're learning through textbooks. I'm going to tell you a little bit about the practical side and what we need to do to not only secure our systems but make them run well. And I hope some of my stories that I may provide you guys will help you in a new career, or if you want to just learn a little bit more about what Linux is and how it integrates into an enterprise environment. Again, this course approaches the practical side of Linux system management. No special skills are required for this course. I'm going to be diving into some basic concepts, and I'm going to talk about some of the deeper concepts. So we're going to go over Linux commands, and basic commands, and we're going to go over some of the more intricate security tools as well provided in Linux, and try to help you understand as a whole how to manage systems, or how to manage systems better. So while no special skills are required for this class, and there's no technical portion of this course, I will give you the tools that you can use to explore these topics on your own. This course is very heavily screen focused. So I may only be on camera here for about a third of these videos that you're going to see. The modules in this course cover 4 different topics. The first module will introduce you to Linux in an enterprise environment. The second one will examine configuration within Linux. The third will explore users and authentication and authorization. And the fourth one is going to cover hardening Linux and Linux security. At each end of a module, you will have a quiz. And at the end of the course, you will also have an exam. You must pass at least 80% of these exams, these graded quizzes, in order to pass this course. The project at the end of the course also will need to have a passing grade for you to pass this overall course. But the project is designed for practicality in system management. So I hope what I teach you over these next few modules will help you with those projects. So a majority of servers around the world run Linux. It's estimated that 95% of the internet actually runs on Linux. So coming across Linux in system management is a given. So even if you're not a Linux system administrator, you're going to have to deal with it at one time or another. So I want to teach you what you may experience throughout your career as a system administrator, and why we do things with Linux the way we do them. So whether you're wanting a deeper dive into Linux or just wanting to maybe advance your career a little bit, I hope these will be valuable. So I'll see you in lesson 1.
Hi everyone, my name is Greg Williams. I'm a lecturer in the computer science department at the University of Colorado, Colorado Springs. Wanted to introduce you to myself for a few minutes and tell you a little bit about these courses that you're going to be taking and my passions in computers. My passion in computers really started back in the 80s, where my parents say I changed my dad's computer. It was running DOS at the time. I changed the time on it because he couldn't figure it out. So then when I, in high school, started taking some C programming classes, and then in college, my undergrad, I got my information technology degree, and then got my master's in engineering in information assurance. That's a computer science degree. My passions in computer security are really identifying malicious content and helping identify it faster. My thesis was on identifying external data breaches, internal data breaches from external networks. The paper was actually called External Detection for Internal Data Breaches. That's what it was. Anyway, going back to where I came from in security, I still do love playing video games. And back in the early 2000s, we would play, me and my friends would play Battlefield 1942. And there was a Desert Siege mod that came out, and I would rewrite the memory locations on the fly to turn the enemies a different color so I could identify them easier. So yes, I was a hacker back then. But that really started me into my computer security career because I was able to see that other people like myself had an advantage. And how do I stop other people from gaining that advantage? So now I still play video games all the time. Love playing first-person shooters like Battlefield. Within the past week, I've played Battlefield 1 and Battlefield 4 and played Diablo, all kinds of different games. I do play games with my students occasionally, so if you send me your gamer tag, it'll be after the course, that is, after you've completed it, then we'll set up a channel or something like that. Anyway, so I've been the information security officer here at the university and the HIPAA security officer, but my passion now is being able to apply computer security into the systems that I manage. So being the director of operations, which includes telecom, it includes all networking, it includes infrastructure for what we would call a medium-sized university, which is 13,000 students. It gives me the opportunity to innovate again. We're doing some really cool things. So I'm going to take you into the data center right now, and we're going to just look over a few of the things that get me really excited about computer security and also system management. But before we do that, what I want you to understand is that everything that you're going to learn in these courses, if you're just taking the system management and security specialization, or if you're taking the computer security or the practical computer security specialization, what I want you to understand is that this is practical knowledge that I've had from years of experience. I live and breathe this stuff every day. You're going to walk into the data center here in a second and see that this stuff really does exist. This is really what I'm putting into practice, not just theory. My teams live and breathe this stuff too. So it's a combination of learning all the time, but also practicing. And I hope that you see that throughout these classes. Let's go take a look at the data center. Okay, this is our primary data center. We have a raised floor system here. Underneath the floor is 24 inches of space. What that does is that allows cold air
from the crack units behind me here to be pushed down through the floor and cold air going up. What that does is that pushes the hot air up to the ceiling. The ceiling in this room is around 17 feet tall. But you can't tell because of the tiles. We have quite a few standalone servers, but let's take you into where we have a lot of rack mount units. This is one of our newer racks. Each one of the racks here contains almost $500,000 worth of IT equipment in it. Very specialized hardware and software that goes into everything that we do here at the university. Systems like these run, and these down here run our media department's servers, and they store video on them. Standalone servers for random things. This is our SDN stack, software-defined networking. This is one of the really cool bleeding edge or cutting edge technologies that is out on the market today. It's actually Cisco ACI. What it does is it works with virtualization and physical systems to software, based on the software, route packets back and forth and do microsegmentation on the network. It's actually the core of our network, not which many universities have at the moment, or really not many more organizations. Down at the bottom, we have some of our virtualization architecture. We have storage in this cabinet. Like I said in the previous couple minutes ago, this is just our primary data center. We have 4 data centers on campus. Some have more equipment in them, some have less. We also have 54 buildings on campus. Each one of them look around like this. This is our networking row. Each one of these racks, or each one of these red wires, goes to a port somewhere in the building. Orange wires go directly to servers or other internal architecture. This is our core router. Each one of these in here go to a building. Each building on campus is dual connected, meaning that if somebody cuts one of the fibers, the other one kicks in. And here's all the connections to our buildings on campus. We have more standalone servers and network architecture in the back, and then even more we could keep on going. But what I want you to understand out of the entire course, as you're thinking about these videos and you're watching these lectures and doing the work, think about how you are implementing this technology, or how you want to learn this technology for an organization. Feel free to email me. I'll be more than happy to take a look at whatever you have and help you out if I can. Keep in mind, I practice this stuff on a daily basis. This isn't just me talking theory. Most of the stuff that we talk about is from situations that we've had here on campus or lessons learned. So I will see you in the next couple weeks.
In today's lesson, we're going to talk about Linux in the enterprise. So what is Linux? And how is Linux used in the enterprise? We're going to discuss what Linux is, what devices it's built into, and why do we actually care? I know you're taking this lesson or this course because you want to learn about Linux, but why do we care about Linux in the enterprise? how much do we need to take Linux into account when we're thinking about everyday computing or even enterprise computing? So what is Linux? Linux is an operating system. In order to be called Linux, it needs to have the Linux kernel. So it's used for a lot of different technology, such as TVs, thermostats, small little computing devices, our phones. Okay, it's estimated that 95% of the internet runs on some type of Linux machine or server. Okay, 99% of the supercomputers in the world run off of Linux. The others run off a couple different things like Unix, and there's some other operating systems. I think Solaris may be still out there. Anyway, 99% of supercomputers run off of Linux. Android, the operating system for our Android phones, okay, those are 2/3 of the world's phones. In the US, it seems a little skewed because Apple devices have become so popular. However, in most of the world, well, 2/3 of the world runs off of Linux phones, Android-based phones. So, brief history on Linux. So, back in 1983, Richard Stallman created the GNU project, spelled GNU. Okay, the goal was to create a basically Unix-compatible software system that was composed of free software. So in 1985, he founded the Free Software Foundation, which is still run today. He wrote the GNU GPL, which stands for the General Public License. So GNU is a recursive acronym, actually, that stands for GNU. GNU is not Unix. Okay, so GNU is not Unix. GPL is at version 3 today. Some people like it, some people dislike it. There's very opinionated posts from certain individuals in the Linux community that very much dislike it, and you can go out and search who those are. But it keeps on evolving. So in 1991, Linus Torvalds basically wrote the first Linux kernel, and it's still being used today. Started to take off in the 90s when it was adopted by larger corporations. So today, Linux keeps on evolving. We start to put it in absolutely anything. If we look at some of the operating systems that are out there for Linux, we actually see one of the smallest operating systems out there only runs on 50 megabytes. Compare that to your Windows machine that takes up almost 20 to 25 gigabytes of data. Linux can be morphed into nearly anything you want it morphed into. Okay, Linus Torvalds is still one of the primary contributors to the Linux kernel today. There are thousands of distributions out there and have been over the past, 25, 26 years that it's actually been out there. So why do we care? I guarantee you somebody has something right now. You right out there right now have something that runs on Linux, whether that's a thermostat or whether that's your TV or a car or music player or all kinds of different things. So we need to understand how Linux works in order to integrate it into other systems. So industrial control systems, web servers, file servers, DNS, big data systems all can run on Linux. There's some things that Linux does really, really well, like web servers, for example. We run Apache, for example, or Nginx on Linux. I run large big data systems on Linux, for example, with Splunk. Okay? Linux can be used for all kinds of different things. Domain names system, for example, DNS. We run several Linux systems that run DNS for the university off of Linux. So what is Linux really good at? Well, you name it, there's probably something out there that somebody has an opinion on that Linux runs the best version of it. So maybe it's directory services, or maybe it's web servers. Somebody's going to have an opinion on it. I have always been of the opinion that you use the best software for the type of application that you need to run. So it doesn't matter if it's Windows, doesn't matter if it's Mac, doesn't matter if it's Linux. But there is something that somebody has an opinion about. And Linux can usually run all kinds of stuff. So Linux is really good at, you name it, a lot of different things. So web servers, Apache, Nginx, a lot of different things. It just takes time to figure out and program. With Linux, we need to take our time because Linux is very unforgiving. So if you do something in Linux, you generally can't back out of it. Unless you're using virtualization technology, that is, and you have snapshots built into everything. Or backups of stuff, which you should have anyway. So it just takes time to play with. Open source software is abundant. However, we need to understand how everything works together in order to make sure it's a good system. So some of the pitfalls of Linux. You have to understand how it works. So you need to take the time and invest in, is this upgrade that I'm going to do affect other software? So for example, I spun up, I have this very large security type system that's doing analysis on certain things. And I upgraded one of the packages. Well, that completely broke and I couldn't undo it. PF ring modules that looked at my network interface card. Okay, that split. PF ring is a software package that basically splits up the connection into multiple kernels or multi-threaded instances of the network. So it splits up all my packets, okay, and processes them differently. Well, the primary focus of that system was to do security on network. So now I've broken the system because I upgraded one package. Now, it's much better today, but it takes time to learn how much time, it takes time, again, to figure out how all this stuff works. It's a different way of thinking, and we need to keep up with the technology. So in conclusion, a system administrator is going to encounter something Linux throughout their course of system administration, throughout their career. Well-versed Linux administrators are always in demand. Whether you get your Red Hat certifications, whether you're a Red Hat certified system administrator or a Red Hat certified system engineer, Red Hat certified engineer, or a Red Hat certified system architect, you're going to be in demand. Since Linux runs quite a bit of the internet and most companies run a lot of stuff on Linux, you will always have a career. In today's lesson, we're going to discuss Linux distributions. So Linux distributions are anything that contains the Linux kernel. So we're going to be discussing a little bit about the kernel and how distributions work, what types of distributions there are out there, and a little bit about how we can build our own distribution if we want to. So in order to be called Linux, again, we have to have the Linux kernel. We have different forks of the Linux kernel. We could run version 2, version 3, all kinds of different versions out there. So the kernel is constantly being updated by hundreds of developers all over the world. I said it in the previous video, but Linus Torvalds still is one of the primary contributors to the kernel. The kernel is the core of the operating system. It is what makes Linux Linux. It has different modules built in and ways that it interacts with hardware to really make it an operating system. So each distribution of Linux has its own kernel, and it usually has a package management system that is used for building other software on top of that kernel to make what we call an operating system that you would use for different applications. So some distributions may be heavily focused on web content, some of them may be focused on security, some are forensic software. We can do all kinds of stuff with our Linux distributions. There are literally thousands of distributions out there because people can make their own. So developers out there create all different forks. I personally run probably around 7 or 8 different distributions at my home. Or even at my desk, I probably have 15, 20 different distributions used for different things. Now, all those working together, I use virtualization technology to run them all at the same time, but let's say I want to execute a virus. Well, I use a certain Linux distribution to make sure I don't infect my main system. Or penetration testing, for example, is another distribution. Or if I want to bring up a web server, okay, all those distributions are custom built by people that have very specific criteria in mind about what they want to do with that operating system. So a distribution may also include, including the kernel, open source tools and libraries, a window manager. A window manager is a GUI interface to the operating system and how we actually interact with the kernel. So maybe we don't have a GUI, but we still have to have a Windows manager to interact. Okay. Also a desktop environment as well. So desktop environments may include such versions as like KDE or GNOME or XFCE or Flux. There's a whole lot of them, depending on how easy they are to use. So while most distributions are open source, meaning that anybody can use them, some of them aren't. So Red Hat, for example, Red Hat Enterprise Linux, or you may hear RHEL, R-H-E-L, those distributions are paid for because of the support that they have behind them. So if we have an issue with our Red Hat systems, we may call up support and say, how does this work? The benefit of having support behind some of those enterprise systems is because we know they are maintained. We know that the security patches are always going to be there. They're always working together to come up with a solution that works for that operating system. So how do we decide on which distribution is right for us? Well, really, it comes down to what you want to do with it. What I said before, we have security distributions, we have forensics distributions, we have normal computing, desktop, web server, networking, we can run firewall distributions, we can run all kinds of stuff. So we need to find which one is going to be best for us to use in a certain use case. Some other considerations are also, what about support? So some of the distributions out there are much more supported than others. So Red Hat being the one that's going to be the most supported out there, yet cost money. Ubuntu has also come out with they release 2 distributions every year. So they release a version in October and they release a version in April. So for this year, for example, 2017, they'll come out with 17.04 and 17.10. So in the even number of years, they release long-term support distributions, meaning that whatever they develop for that operating system and integrate, the packages that work with it will be supported for many years. So the odd years or the off-schedule ones, so like 1604, for example, was a long-term support or LTS version of Ubuntu. So depending on if we need support or not goes back to how long do we want to use this thing? Does the distribution stay up to date on certain packages? Because Linux is open source and a lot of versions are open source, it really comes down to are the developers constantly evaluating the patches? And how difficult is the distribution to use? If it's clunky, it doesn't make sense with the hardware we have it on, if it doesn't work with the virtual machines, maybe it's not a good distribution for us to use. Additionally, do we really want a GUI interface on a web server? Probably not, because we're going to be using it command line only. Okay? We need to have these considerations in mind before we deploy a distribution. So the major distributions, distrowatch.com has a lot of information on all kinds of distributions. There's something being released all the time. So major distributions include Red Hat flavors like Fedora and Scientific Linux, and CentOS is, or also pronounced CentOS, depending on who you talk to. CentOS is a 100% compatible version of Red Hat. It's just open source. Debian also includes versions like Ubuntu or Knoppix or even Mint. Somebody that wants to get into Linux just for testing it out and for using it as a desktop may use Mint because it has a lot of drivers in there that we can use to watch video, for example. If you want to use it for your home computer, it's a great way to dive into Linux. Okay, we also have Arc and Gentoo and Slackware. So custom examples of Linux distributions: Android for your phones, routers, DDWRT. For security, we have Kali Linux. For the Internet of Things, Nest, Raspberry Pi, and for privacy, Tails Linux, for example. So in conclusion, Linux distributions come in all shapes and sizes. Some are large, some are small. It's really up to the system administrator to decide what is the best distribution for us. In this lesson, I'm going to discuss installing Linux. The installation of Linux varies by distribution to distribution. However, the tasks involved are pretty much the same. First, you're going to need installation media. In this case, I have a virtual machine, so I've put the virtual disk into the virtual drive and started up the installation process. The first screen that comes up is the language screen. I'm going to select my language as English and press continue. The next screen that comes up is the installation summary screen. There's only a few options on this screen, but each of these options goes into other configurations. In order to set the time and date, I need to set this automatically. So I need to turn my network card on so it obtains an IP address. Once the IP address has been obtained, I can go back into my time and date and select my time zone. The time automatically will be updated if I do this. The next thing at minimum that I have to do is select the software installation or the software selection. CentOS, which is this operating system, comes with a few options that I can use for various software to be installed in the system. Each one of them on the base environment allows me to select different software packages that will work with the server. The next screen shown here allows us to configure the virtual disk, or if you're running a physical disk, it'll show you all the physical disks that you have. If there's no space available, you can't install the operating system. So in this case, I need to delete volumes. This can be done manually by selecting the minus sign on the screen. If the disk is new with no information on it, I can select or click this button here, which is click here to create them automatically. Doing this will set the defaults for the disk. If you've selected manual volumes, it's going to show you the changes that you have made to the disk. Now that I've completed the basic installation options, I can start the installation. What this is doing in the background is it is installing the system. It's installing all the software that's needed based off of the selections that we chose, and it's configuring the system in general. One nice thing about this installation is it allows us to set up users and passwords for those users while the system is installing. So at the end of the installation, all I'm going to have to do is reboot the system and agree to the terms of use, and then just log in. So after I press reboot, it's going to start the booting process. On first startup, we need to agree to the terms of use. So here's the license information, and it's going to ask me to accept it. It's now going to finish the installation of Linux. Notice how the information that I filled out for the username and password is already ready for me the very first time I boot the system. The first time I log in, I'm going to get a couple screens asking me how I want to use the system. So I'm going to use English as the language and make sure the keyboard is correct. I can connect my online accounts on this screen to automatically log in to certain accounts. Now the system is ready to go. In this lesson, I'll talk about Linux and networking. Networking within Linux is a little different than your traditional networking within OS X or Windows. Traditionally, with Linux servers, we don't have a GUI, so we need to operate everything from a command line interface. That makes troubleshooting a little bit more difficult. When we're a Linux system administrator, we may be asked to statically set information on the network so that we can get to our server all the time. While DHCP provides us an IP address right away every time, it may provide us a different IP address every time. So we need to configure the IP address from the command line to ensure that we get the same IP address every time we try to access that server. Let's look at both the GUI side and the command line interface. Different distributions handle networking different ways. Some call things certain ways and some display information other ways. So in order to find the GUI configuration for networking, you'll have to search for it. In this case, it was under Settings and then Network. This is the Network Manager, which is traditionally the piece of software that is used in GUI to manage your interface connections. In order to modify these, I'm going to click the wheel, go down to IPv4. Notice that it's set to automatic DHCP. I may want to change the DNS address. Here is where I'm going to change the static information for my server. So I would type in the address, the net mask, and the gateway. Now for the command line interface. In order to see what the interface is called, I need to look at what we have in the system. So I'm going to type in ifconfig, and you'll notice ENO with a number after it. This stands for Ethernet, onboard, and then the arbitrary number after it. Additionally, we have our loopback address, and we may have other different addresses in here for virtualization, for example. If I were to modify this interface, I'm going to type in sudo ifconfig and then the IP address. I need to have the IP address that I want to enter plus my net mask. Those two need to be known. I also need to enter in the actual interface that I want to configure. Once I hit the enter button, it's going to change the system. The other thing that I need to do, I'm not going to actually modify that, but the other thing I need to do is change the route. The route allows us to have a way to get to the next hop. I can change the route by typing route, add, and then the information that I want to, the router information that I want to add, and the destination. So if I want to change certain routes for certain interfaces, I can do that by just typing in route add and then the information. So if I wanted to add 192.168.122.1 for ENO 16777736, it's going to change the default, it's going to change the route for that interface. However, I don't want to do that because it's working just fine right at the moment. In order to see if things are working correctly, I'm going to ping resources. So I'll type in ping and then a name. I should receive a response back, which means that both my route is working and my DNS is working. If my DNS is not working, I can try just pinging the gateway and see if I get a response. If I don't get a response from the gateway, then I know there is something wrong with my system. Let's look at how we configure the network interface if we need it to be persistent. The way I just showed you will reset once I restart the server. So I need to have that information saved. This is located in etc sysconfig network scripts and the interface that I need to configure. So ifcfg-eno and then the number after it. Here's the information on that interface. If I needed to set a static address, I'm going to change the boot protocol from DHCP to static. I'm also going to need to add the IP address information and netmask. This is very easy, where I would just type in IP ADDR equals 192.168.0, let's say, .2, and my netmask is 255.255.255.0. However, since I don't want to modify this at this point, I'm going to quit out. Now let's say that we want to protect certain resources. Within Linux, it's very easy to create another interface, especially virtual, and isolate certain resources. I can do this with firewalls and my interfaces, and by modifying the routes. You may see this in a more secure environment. In conclusion, troubleshooting with Linux is not difficult. However, you may have to learn additional commands in order to get familiar with the interface. In this lesson, I will show you how to interact with the sudoers file, grant sudo privileges to certain users, and allow them to execute privileged commands with or without a password. Sudo is a program that allows users to run programs on behalf of another user, typically the super user or root, and it can be configured by the sudoers file that specifies how sudo access is granted for a given user. In order to view or modify the sudoers file, you must have super user or root privileges. I'm using the Greg account so that it is not privileged at the moment. In order to elevate my privileges, I'm going to log in as root. Now I am root. The sudoers file is located at etc/sudoers. The sudoers file should not be edited with a normal file editor, so we're going to use vi sudo. I'm going to scroll down here to where we actually modify parts of the sudoers file to grant certain access. This line right here where it says root all equals all in parentheses and then it has a tab and it says all again means certain things. This line means that any user with the username of root has access to execute all commands if the root password is entered. Obviously, the root user should have these privileges already. Each line should have the following elements. First, the user the line applies to here is called root. Next, the host, which the line can be applied to, in this case, all. This is useful if you're copying the file from system to system. Next, the equals all specifies the users which the person running the sudo command must be. In this case, all users. And finally, the commands which the specified user can run, in this case, all commands. Let's add a user here. So I'm going to press I for insert because I'm in VI. I'm going to type in Greg_test. I'm going to hit the tab button, not the space button. Tabs must be used here instead of spaces in order for the file to work correctly. Okay, so I'm going to execute the same commands. All equals all in parentheses, tab, all. Okay, so let's right quit. Now that I've saved the file, let's try to access VI sudo from what I just created. Sudo or VI sudo is a privileged process, so we need to execute it as root, as sudo. So su Greg_test. Now notice that my username is Greg_test. So sudo vi sudo. Enter my password again for Greg test. Hit enter, and now I have access to the sudoers file. Let's say that we don't want to have all users use full super user privileges all the time. So now let's modify Greg test 2 in order to run fdisk without a password. Go down to the line that we created just a little bit ago. Type in Greg test 2 all equals no passwd tab. Remember the all, this third string here is for commands. We'll type in sbin fdisk. Now let's switch users. And see if we can't run that command. Whoops. So notice how I didn't have to enter a password. Typically when you run sudo, we have to enter that password. Now let's look at what sudo also provides. Sudo also provides information on what we just entered. So let's look at sudo, well, let's exit out of here, and we'll exit out of Greg test. And let's look at sudo tail -3 var log secure. Notice how all my commands are logged. Sudo provides information on everything that the user types in, as long as they are using sudo. If we don't want them to sudo, then we have to not allow them to do that. However, if they're in the sudoers file, we can lock those commands down as well. In conclusion, sudo provides a way to provide access to users on behalf of the root user. This is important to do because sometimes we need to elevate privileges. What this allows us to do as well is make sure security is still intact. So what if we accidentally type something in? Well, sudo prevents us from accidentally typing in a command that we may not have meant to type in. So anytime we type in sudo space and then the privileged command, we're going to be prompted for that password, and think about it twice. So in an enterprise environment, it's best to enable sudoers for your Linux systems. So they have the ability to do administrative things, however, lock down the system to understand what they're doing, to know what they're doing. Logging information is important as well. In this lesson, I'll discuss SSH, or Secure Shell. I'll discuss what SSH can do and how we practically keep it safe from attackers. SSH is turned on by default on most systems. We can check that it's running by typing in ps aux grep SSH. The SSH daemon here, located in user sbin sshd, is running. It's very easy for us to test if SSH is running on a remote host. It's so easy because typically SSH runs on port 22. We'll discuss how to secure it in a little bit. SSH has many security features built in. SSH is capable of shell access, file transfers, executing remote commands, port forwarding and tunneling, creating VPNs, forwarding X displays, that's our GUI, encrypted proxy browsing via the SOX protocol, and mounting remote directories. Typically, a system administrator is going to use SSH to copy files. This comes in the form of SCP. SCP works nearly the same way as SSH, but there's other things that we can do with SCP. We can actually transfer files and zip them up at the same time over SCP. I've done this with numerous systems, and it saves a lot of time in the long run if we're backing up systems. The command SSH looks like this: SSH username at hostname. Okay. We could also issue command after it if we want to. So we could say ls-l if we would like, without the square brackets. File copying via secure copy, or SCP, is as simple as typing SCP, the file name, user at host, colon, home, or wherever you want, wherever your files are located, home, user, file name here. Okay, this is based on Secure File Transfer Protocol, or SFTP, but it's not meant to replace RCP. Let's test this out. Look up my IP address by typing ipconfig. Here, my interface is 192.168.18.131. I'm going to go over to another distribution called Kali Linux. Kali Linux is a security distribution aimed at penetration testing. And I'll show you why here in a minute. So we're going to SSH greg at 192.168.18.131. It's also going to ask me the first time that I establish a connection what the fingerprint of the machine is. I'm going to type in yes. What this does is it keeps a list of known hosts. This way, if a server were ever compromised, or if I ever tried to connect to this IP address again, and the 256 SHA hash here doesn't match when I connect to this again, it's going to deny the connection. So notice that I've able to successfully SSH'd into the system. Okay, who am I? Who am I is a command that I run to see who I am. Let's look. Okay, here is my home directory that I had created the other day. And when we SSH in, it's going to go into that folder. So SSH is a pretty commonly attacked port. And if you have port 22, which is the standard port for SSH open to the internet, you're going to get a lot of attacks. The way we need to solve this practically is by editing the port so that it doesn't answer on port 22. We need to change that to something that attackers are not going to try. Typically, attackers scan for well-known ports and move on if they don't find anything. So let's bring up an application called Nmap. And just for GUI purposes, I'm going to call up ZenMap, which is the GUI interface to Nmap. So I'm going to scan 192.168.18.131. Right now, I'm going to do a quick scan. A quick scan, denoted with -F, looks at very few ports. It looks at the commonly known ports. So if we scan really quick, we'll notice that it comes back with port 22 TCP is open and it's running SSH. It also gives me the MAC address, and obviously we know the IP address because that's what we typed in. So we need to change the SSH port. So we'll go back to CentOS, and we're actually needing to log out, so let's exit and close the connection. And here on my CentOS system, I'm actually going to change the port that SSH is running on. In order to do that, I'm going to type in vi etc ssh sshd_config. I'm going to scroll down to where it says port 22 and uncomment that line. I'm now going to change that port to 2237. I'm going to escape, write, and quit. Because this is CentOS 7 and SELinux is turned on, I need to make sure that SELinux knows that I'm making a port change. In order to do this, I'm going to type in semanage port-a-t ssh_port_t-p TCP, then the 2237. Okay, so what this does is instead of listening on port 22, it's now going to listen on port 2237. And I have to allow that with SELinux. It's going to think about it a minute. And now I'm going to look at semanage and make sure that it actually took. So I'm going to type in SEmanage port-L, so listing the port, and I'm going to grep for SSH as the service. Okay, it looks like SSH port-T is listening on now both port 2237 and 22. This is okay as long as we change, which we did, the port that SSH was listening on. The only thing that we need to do now is restart the SSH service. In order to do this, I'm going to type in systemctl space restart space sshd dot service. And let's make sure that SSH is still running. ps aux grep SSH. Okay, it's running again. So let's try connecting back with Kali Linux. Okay, looks like now I can't SSH into it, but let's type in SSH-P2237 Greg at 192.168.18.131. Let's try to scan our port again and see if it comes back with anything. Okay, now port 22 is now closed. The next thing that I have to do is open the port in the firewall. We'll talk about firewalls in Linux in a couple lessons, but first let's open up the port. The new firewall within CentOS 7 in Red Hat versions is called Firewall D. So I'm going to type in firewall-cmd --zone equals public --add -port equals 2237/TCP. Now I'm going to go back and double check that I can't just see port 2237 open. This shows us that port 22 is open on the firewall, however, there's nothing listening on the port, which is okay in this case until we actually delete the rule out of the firewall. So I'm going to change this to an intent scan and see what it comes back with. This may take a minute. Notice that not even our intent scan denoted with an A actually finds anything. So port 2237, while it's a low numbered port, it's not low enough where attackers are going to continually scan it. So it's mainly hidden from attackers. This is called obfuscation, where we're hiding things out in plain sight. If you have SSH turned on port 22 on a public IP address, you probably notice that you're getting attacked quite a bit. If you change the port on SSH, you'll now see that you're able to hide your port and it's not going to get attacked. Let's just make sure that we can actually SSH in now to that port. So I'm going to type in SSH-P for port, and the port number is 2237 Greg at 192.168.18.131. And notice that I can get in now. Understanding that you can hide SSH in plain sight is critical to make sure that your attack surface is lowered. Changing port numbers will help you not allow attackers to keep on trying the same service over and over and over again on port 22. In addition to changing the port, there is another risk of SSH. SSH allows us to enter a password for a user. However, if SSH were ever compromised and an attacker were to change the binary of SSH, they would be able to turn SSH into what we call a honeypot and steal users' credentials. So it's important to also look at other technologies such as two-factor authentication for SSH. This can be done with public and private keys. This also allows us to streamline SSH between systems. So in conclusion, SSH allows us to access other systems, but there are some security vulnerabilities that we need to be aware of when we're implementing the service for users. Changing the port and looking at authentication will go a long way in securing SSH. In this lesson, I will talk about CRON, what CRON is, and how to use it, and some use cases that I've used in the past. CRON is the command for periodic processing within Linux. Periodic processing is necessary to make sure systems are functioning correctly. Think about how we execute backups at certain times on certain systems. For a Windows backup, it's real easy. It's done by a scheduler. For Mac, it's the same thing. It's done by a scheduler. So why would Linux be any different? CRON is our scheduler. CRON allows us to execute anything we want to arbitrarily at certain times of the day, certain times of the week, and essentially any time that you want it to execute, we can make it run whatever you want it to run. It's more powerful than a lot of the other periodic processing tools on other systems. The benefit to using CRON is it's also very easy to manipulate. In order to access cron tab, we just need to type in cron tab -e. This opens up our cron tab for E for everyone. So I'm going to create a new cron tab. Cron tabs come in the form of a configuration file that start out with how we want to process that, or what time of the day, what time of the week, really what time that we want to process the command at the end. The first star indicates a minute, so minutes 0 through 59. If we want it to run every minute, I could say divided by 60. The next is going to be hour. The next is day of the month. Next is month, and finally day of the week. So I should have 5 configuration items for the time period that I need to process this command. Next is the command that I want to run. If I want to run a certain command, I'm going to type in root scripts cron_test.sh. This is a shell script that I created to test cron. If I right click, I see that my cron tab is successful, installing new cron tab. I can look to see what is running by typing in cron tab-l. Now think of cron tab as a scheduler for almost anything, just like I said before. It allows us to back up information, allows us to check on systems. Some of the use cases that I've used cron tab before is testing network to make sure that systems are up and running, to make sure wireless access points are up and running. And if they're not running, execute another script to restart those wireless access points at a certain time. By default, CRON sends an email to the user account that is executing the scripts. So in this case, because I'm root and I edited my CRON tab, I'm going to receive a lot of emails to the root email account, which luckily isn't set up. However, if I didn't want to receive emails, I also need to type in an additional command after my script. So let's go back into CRON tab, and I'm going to take the standard output and actually push that into what we call dev null. We're going to take the standard out and call dev null. And now we've successfully installed our CRON tab again. Let's look real quick at where we can go to look to see if CRON is actually executing or not. There's a log file located in var log cron. And we can see that we are executing, or that we have loaded our CRON tab. So in conclusion, CRON tab allows us to do periodic processing on Linux systems. It is a very important part of a system administrator's duties to make sure that our systems are run well, and to make sure the backups are being completed, and also to do periodic processing on anything we need to run automatically in the time that we choose to run that script. In this lesson, I'll discuss adding users to Linux. Adding users to Linux is a common task that system administrators may perform over the course of managing a Linux system. Now, depending on what scripts that you might have implemented on, let's say, a Kickstart file, for example, the integration that we have with maybe another directory like Active Directory may do some of these tasks for you, but let's go over them individually. So I'll discuss the commands that we use to enter in users into Linux and some of the caveats that we have as well, and what I've seen over the years. Now, most Linux systems use a command called user add. Now, if I type in sudo user add and then the account that I want to create, it's going to create not only the home directory, but it's going to create the permissions for that home directory and also the shell that the user is going to have as well. So I'm just going to enter this here and enter my password for Greg, and now the account is created. I can check that the account is created by doing one of two things. Since I'm already in the home directory, I can just list what files I have. So here's my account, G. Williams, and G. Williams is the user and the group owners of that directory. Additionally, I can go into the etc password file and look to see if the account was created there. But before I do that, let's add a password for my G. Williams account. So I'm going to type in sudo passwd G. Williams, hit enter, and enter password, retype the password, and it's created the password successfully. So let's look at the etc password file for a minute. Here, we'll notice that we have three different users. I have Greg, Greg Test, and G. Williams. The X indicates that I've set a password for that user. I have a user ID, as well as my home directory, and the shell that that user has. Since some of the scripts, because different distributions use user add in different ways, let's look at a more mainstream Linux distribution, such as CentOS, which is the binary equivalent of Red Hat. Typically, we're going to see this distribution being used more in an enterprise environment. So let's get more familiar with what we can change for the defaults. So I'll type in sudo vi etc default user add. So here I can change the group, I can change the home directory, inactive, I can make it active, when the account expires, and the shell, and the create mail spooler. I can change or I can add several other attributes if I would like, but these are the most common that I'm going to use. Now let's go back into the etc password field. On many of these, we notice that there is a shell called sbin no login. This means that we're going to use an account, which is basically a service account, that allows us just to use a service and execute commands, but it doesn't allow the user that we create to log in anywhere. If we want to lock a user out, this is the quickest way to lock somebody out of their account. This would be in the cases if we wanted to, if somebody was leaving the organization. So in conclusion, adding users is a very easy process. We need to understand how we create users and what fields that we need to enter to make sure that we're setting permissions correctly and that the user has a good experience when they log in. In this lesson, I'll discuss securing users. Securing users within Linux is pretty simple. Some of the commands that we've used already, like user add, create files and permissions for users when we add them to Linux. However, if we need to modify something, there are other commands that we need to use. In this lesson, I'll talk about some of those commands and why we want to use certain commands over others. Let's look first at what we've already created. So we'll type in sudo cat etc password. We now have our 4 accounts that we've created. Here's our accounts right here. Now let's say that we want to modify a home directory. So for the user Greg, instead of home Greg for my directory, let's use Greg temp 1. Okay, just to make sure it's there, let's type in ll home. Here's my directory that I just created. However, the user and group are both root. We need to change that. So we'll type in sudo chown, the username that I want to change it to, the group that I want to change it to, and then the directory. So if we look at that folder again, now we'll notice Greg and Greg are the owner and the group of GregTemp1. So now we can modify our etc password file to reflect these changes. In order to do that successfully, we need to use a different command other than going into etc password. The command is called VIPW. What this does is it not only locks the file, the etc password file, from other users changing that file, but it also syncs the passwords. So I'm going to scroll down and I'm going to change user Greg. Into Greg_temp1. Right quit. Okay, now you'll also get a warning. You may need to modify etc shadow for consistency. Now this is only if I am changing certain other characteristics with the user. And I can use VIPW-S to do that. That will allow us to change and lock the etc shadow file. Let's also look at the groups really quick. Securing users not only ensures that we are securing a user and making sure that they own the files that they need and locking out others that might have access to those files, but also modifying groups so that we can let other users make changes to other users' directories, or if they are sharing files, to lock certain people out of other areas in other people's files. In order to do this, I would have to modify the etc group file to allow other users to be in that group. In addition to adding users and making sure that their home directories are correct and their shell scripts are correct in the etc password file, we also need to think about removing users. This is a common occurrence with organizations. If somebody leaves, we not only have to remove the file, but we also need to search for anything that the user may have left behind. When we delete a user, we're going to type in the command userdel. I'm just going to remove Greg test3. Remember, you have to use sudo here. Userdel Greg test3. Let's look at the password file. Okay, Greg test2 is there, but Greg test3 is gone. Now, when we have a user that has left the company, we also need to make sure of a couple other things. We need to remove their access from any local databases, remove any alias files that they have, remove any cron jobs. We need to remove the user's home directory or their mail queue and any other files that they may have had on the system. So let's check to see if we have any other files out there. Let's type in ll home. You'll notice that not only is Greg test3 still here, but now it has no user or group associated with it. However, it still has the security ID. So we need to remove that directory. In order to remove somebody's files, I'm going to type in sudo rm-rf greg test3. Now, make sure that you are in your correct directory before typing RF, because that stands for recursive and force. This is permanent, and if you're in the wrong directory, it's going to delete everything in that directory. So is it still there? No, it's removed. Let's also make sure that we don't have any lingering files for the user. In order to do this, we're going to type in sudo find, type in / and xdev no user. What this does is it looks for any files out there without any user associated with it. Now this may take a while to search through your system if there's a lot of files on the system. It looks like the system has found another place where we have forgotten to remove some the user's files. So let's remove that directory as well. Sudo rm var spool mail greg test3. Let's just make sure we force. Okay, let's run this command again. May take a minute, and looks like we have no files that come back. So in conclusion, we need to be very careful about how we manage users within a Linux system. It's not like a Windows system where we can just delete a user's files or just delete files and they're gone. Files in Linux stay around even though there may not be any user associated with them. In this lesson, I'll talk about Linux and access control. Access control within Linux is typically not used. However, in order to implement least privilege, we need to understand how access control works. What you're typically used to in Linux is permissions. I'll discuss permissions and discuss discretionary access control, and additionally contrast that with mandatory access control, which is SELinux. Our traditional permissions in Linux look a little bit like this. If I'm in my home directory right now, I type in ls-l for list long and my home directory. Here I can see the permissions set on the files and folders of the directory. The D indicates a directory, and the read write execute is for the owner. The next three, read write and execute here, are for the group, and the last three are for the world. So let's say that we wanted to make a file. We're going to type in vi, and let's create this in the greg temp folder, so greg temp, and call this test file.log. I'm going to say this is a test. Okay, so I'm going to change directory into greg_temp. If I type in ls-l, you'll notice that it's not a directory. The very first dash here, I have read write for the owner, who is root. I have read for the group, which is also root. And for everyone else, I just have read. Let's say that I wanted to change these file permissions. The way file permissions work inside of Linux is in powers of 2. So the read is worth 4, the write is worth 2, and the execute is worth 1, totaling 7 bits. So if I wanted to change all 7 bits for read, write, execute for the entire file, I would type in chmod 777 testfile.log. If I type in ls-l, we'll notice read, write, execute, read, write, execute, read, write, execute. This is not a very good practice, though, in theory, because now we've given anybody in the world the power to execute anything that file does. What's worse is if we allow the world to write to it, we could actually change this to a shell script and execute it because of both the write and the execute. So let's change this back to chmod 744 testfile.log. Now we see that read, write, execute for the group, read, write, execute for the owner, read for the group, and read for the world. Let's say that I want to enforce or start to enforce least privilege for users inside of Linux. This is not typically done, but can be. In order to do this, I'm going to type mount-o, remount, comma, ACL, and my mount point, which is going to be the entire file system, so I type in /. Okay, let's just make sure my files are still there. Yep, they're still there. So I've remounted the / mount point just fine. With ACLs, we can add permissions to other groups or users that typically do not have access to certain files. So for example, if Apache is running content owned by a user, this typically should not be done since it's dangerous to allow Apache to run the user or root content. However, we could allow a group with other permissions to access this file. This might be a security risk, but it's better than some of the other permissions that we have out there. We could allow group and other permissions. However, this might be a security risk as well, because every user could look at everyone else's home directory. In order to look at the permissions or the access control on a file, get facl and then my mount point of Greg temp. Okay, so the file is my dot, which means everything in the directory, my owner's root, and my group is root. The user has read, write, execute permissions, the group has read and execute, and for other, or the world, I'm going to have read and execute. In order to do this, I'm going to type in set facl-m for modify. User is going to be Greg, and I want to do read, write, and execute for the home directory. So now if we look at the permissions again, what's going to happen, get facl /home. Now I've added user Greg read, write, execute. If I drill into what I had typed in before, you'll notice that I still have the permissions only for the root on that directory. Let's look at ls-l to see if anything else shows up. Doesn't show up here, but if I go back one directory and type in ls-l again, you'll notice here I have a plus. The plus means that I have extra permissions on that folder. The benefit of discretionary access control is it is what people are most familiar with, and it works most of the time. It's a model that distrusts users and isolates the damage that can be done by other users accessing the directories or the files. However, discretionary access control is limited in a number of different ways. We now are trusting software. We're trusting all programs the user has access to. Programs aren't limited on what they are intended to do, and the programs could have vulnerabilities that may lead to a compromise. If a user has sudo or root privileges, the system can still be compromised by other programs because we're allowing the system to execute things as that user. With mandatory access control, we are limiting the damage. This is SELinux. SELinux allows us to control and have least privileges much more so than we can just with discretionary access control. So in conclusion, permissions within Linux are very similar to other operating systems. However, if we want to get even more granular, we're going to have to implement discretionary access control, not permissions. This is highly recommended on any server that we have multiple people accessing multiple files, especially web servers. Today's lesson will cover working with other systems. Linux works with a variety of systems. No matter what you have in your environment, Linux is probably going to be there. So we'll discuss what Linux may connect to, discuss the purpose for Linux in an enterprise environment, and how we connect to other systems. So it's not all about Linux. Linux system administrators like to think that it's all about Linux and we can do everything on Linux. Well, I've said it before, and I'm really of the firm belief you use the technology that is best in whatever type of application you're using it in. So for user services, for example, in directory services, Active Directory for Windows is going to work best. So use whatever technology that you have available, what is ever supported, which is ever the, maybe you don't have enough money for Windows Active Directory and want to roll your own Linux flavor of directory services. That's fine, but just be aware it's probably not going to be supported the way you want it to be supported. So while you can have Linux in your environment only, that's typically not the way it works in the enterprise. So Linux does not do everything well. What I tell people if they want to start getting into Linux and say, hey, you know, I really need to provide this computer to my friend and they've lost their Windows key and don't want to go get a copy of Windows. Or you know, what about my aunt or uncle, okay, or my parents, for example? Do you want them calling you all the time, telling you how to figure out where things are? There's just some things that Linux is not great at. It's a different way of thinking. While you probably can work your way around a Linux desktop, other people cannot and will get frustrated. If something happens, Linux is very unforgiving. So if we accidentally press the delete on something, can we get it back? Well, some distributions you can, and some distributions you can't. So you need to be careful about how you use Linux in an overall enterprise environment. Windows applications also are at the forefront of businesses. And what about Mac applications from the App Store? Those don't necessarily work on Linux. So if there's a specific software that you need running an emulator like Wine, for example, on Linux, is probably not always the best solution. It's probably best to have an actual a Windows computer to do those kind of applications. Authentication. So Linux can authenticate into a lot of different things, depending on what we integrate it into. So we can join it actually to an Active Directory domain. It serves the following purposes. It serves for security, it serves for file sharing, and it also serves trust. Okay, so security meaning that if we have one logon to our Windows domain, we can use that same for Linux and make sure that we have a one homogeneous environment for authentication that runs off of our Windows platform. However, we've integrated Linux into the Windows environment. Okay, file sharing via something like Samba, for example, also will work as well. Also, trust relationships between different servers if we integrate that Linux system into an Active Directory domain. Linux can be authenticated into the Active Directory domain or with authentication in 3 different ways. So first of all, LDAP, second is Active Directory to LDAP, and then the third one is Active Directory to LDAP and Kerberos. So Kerberos for Windows is the de facto standard for authentication within a Windows domain. And we've seen where Linux, and I'll talk about this in a later video, we're able to have pluggable authentication modules or PAM modules that utilize different services to integrate into different environments. So there's a Kerberos PAM module that we can use to authenticate into the Active Directory domain. We also need to install some other services if we're going to do that. So Samba, for example, and Windbind are also necessities if we're going to integrate our Linux system into an Active Directory domain. There are plenty of tutorials out there on the internet how to do that. And one of them I actually have linked here in your reading for this week. Okay, why do we want to do this? Why do we want to integrate Linux with other systems? Well, in an Active Directory environment, again, we need to make sure security is first and foremost. So if we're integrating users from an Active Directory domain into a Linux domain, we can guarantee that if we shut or disable a user account inside of Active Directory, that person is not going to have access to our Linux system. Okay, auditing is also necessary. So if we tie the two together or tie multiple systems into Linux or Linux into multiple systems, we can audit the entire environment and have a holistic picture of what is going on with our environment. Local accounts should not be used within Linux if it's an enterprise environment. That's for security reasons. Whenever we're installing other open source software, typically we're going to integrate LDAP or lightweight directory authentication protocol, excuse me, to look at authentication between some kind of authentication system and our software. Linux installations may use third-party software for that authentication mechanism. So, for example, Splunk. If you're looking at this specialization from Coursera, we cover Splunk in another module. So I use LDAP for Splunk to authenticate my users in the Active Directory domain. However, my Splunk is running on a Linux server. So software also may require some type of authentication to integrate. So in conclusion, while Linux can stand on its own, it may not be the best use case for a lot of different things. Perhaps Linux is going to be best used for web servers or specialized distributions like for security, okay, or file services or DNS. It's probably not going to be used very much in as a desktop environment, for example. So security is also a major consideration when we need to work with other systems. So we need a holistic picture of our entire environment and integrate all those services such as Samba and Winbind and Kerberos into our Linux environment to make sure that security is always being considered. In today's lesson, we're going to talk about SELinux. We're going to discuss what SELinux is, why we don't just turn it off, and how it also provides least privilege. Problems with traditional discretionary access control, or DAC, we actually have a few problems with it. The first one is administrators cannot control what every user does. So if a user wants to set permissions on their own software or on their own files, they can do that no problem. File permissions and ACLs can't protect you against everything in that case. So read, writes, executes, all those ACLs can be managed by the individual users. Processes can also change the permissions of files or other processes, which may give them elevated privileges. Compromised software may also have access to change permissions within the operating system. So, for example, if you have a compromised SSH process, for example, it might do other things to other parts of the system. SELinux was first designed by the National Security Agency. It stands for Security Enhanced Linux, and it's Linux answer to mandatory access control, or what we call MAC. So DAC stands for discretionary access control, and MAC stands for mandatory access control. It's built into the Linux kernel as of version 2.6. Primarily, it's used on Red Hat type distributions, but it also can be implemented into other Linux distributions as well. However, later versions of Red Hat, such as CentOS, already have this installed and turned on to enforcing. So Linux, SELinux breakdown. It's deny by default. It's mandatory access control. So our mandatory access control says, I'm going to deny anything that I don't know. It provides least privilege. So if we change a file, for example, and we modify the ACL on that file, we're only allowed to do what the SELinux allows us to do, essentially. Another benefit to SELinux is we log everything. So every change, every allow, we have great troubleshooting tools within SELinux to figure out what's going on and who has access to what. We can only allow one exception at a time as well. So whenever we make a file change, we have to tell SELinux, or if it's not allowed, we have to tell SELinux to look at that file again. We have 3 different modes with SELinux. The first one is enforcing, and that one is implementing the mandatory access control on the entire machine. Users cannot bypass it. Everything is logged and everything is denied by default. So the next one is going to be our permissive mode. Our permissive mode says allow everything but log and audit as well. And then our third one is disabled. We don't want to set this at all. We want to make sure that we have at least something that says, here's what things I'm accessing, here's what people are doing to the system. So don't disable SELinux if it's turned on. So types of enforcement. There are 4 different types of enforcement with SELinux. The primary control is going to be our type-based enforcement, and that's using targeted policies. Next is role-based access control, and that's based on users. So if a user belongs to a certain group, let's say that they belong to a confidential group, users of that group may be allowed to access certain confidential marked items. The next is multi-level security, and finally multi-category security. These 2 types of enforcement aren't used as much, but they provide multiple ways to enforce mandatory access control on processes and files. Okay, they are also used in the targeted policy. Okay, the features and benefits of SELinux are numerous, but more specifically, 3 things. The policies are separate from the enforcement. We have great logging enabled, which means that we can understand what users are doing and we can act on enforcement if they're too rigid. Also, we have great troubleshooting tools that allow us to see what's going on, what's allowed and what's not allowed. Controls much of the OS. So SELinux can manage processes, it can manage files, it can really take control of a system and lock it down to the point that we need to have systems locked down. So think about a bank, for example, a web server, and we need certain access to certain things. Well, what if an attacker decides to break into that server? Mandatory access control could limit the data breach that may happen. The problem with SELinux are also seen. So mandatory access control takes time to implement. And if you're making many modifications to the operating system, like adding files or adding processes, SELinux takes time, and you have to allow it for all those exceptions to be made. It is complex. There's a book on SELinux that's about that thick, 400-page book that says here's all the contexts that we need to think about and change if we're going to be modifying different parts of the operating system. Okay, if you make a change to any part of the file system, you still have to make sure that SELinux knows about it, because it's mandatory access control. If we don't set permissions on a file or a process, it's not going to be allowed. Typical usage, we've seen this on web servers, we see it on file servers. It's baked into all the newer Red Hat type distributions to provide that mandatory access control to anybody without installing any extra packages. So in conclusion, SELinux is a very powerful tool, but we need to use it with caution, because it does lock the system down to the point that we need to have high security. However, it is complex. In today's lesson, we'll discuss Linux and security. We're going to discuss what threats Linux has, discuss what items administrators need to be concerned with when dealing with Linux systems, and understand that there's no such thing as a secure computer. Even Linux gets viruses. Okay, so the question I always hear is Linux secure? Well, no computer is ever secure. So computers may be secure at one specific point in time, but it depends on a whole bunch of different things. So it depends on how, where, what software you have on it, a whole bunch of different things to make sure that a computer system is secure. So we can configure Linux in a specific way to make sure that it is secure at one point in time. So if my computer is, Linux computer, is completely off the network and I have all the latest patches, so, or it's, and it's in a locked room, is it secure? Maybe, maybe not. Depends on what threats that it has against it. So maybe somebody could break in the door. If I don't have a password or the hard drive is not encrypted, I can easily bypass the security of that device and get in. So it doesn't matter if it's on the network or not. It doesn't matter if it's locked in a room. So I need to make sure that I have layers of security protecting my Linux system just as I would any other system. It's no more secure than a Windows system, and it's no more secure than a Mac. Everything gets viruses. Everything has problems with users and configuration, unless I follow very strict guidelines. Okay? Linux can be configured in such a way well, that you wouldn't have, or you would mitigate a lot of those security vulnerabilities. There are also some pitfalls that we have when dealing with Linux specifically. Okay, the benefits of Linux for security. Linux, because it's open source, we don't see many viruses being developed for it. We see Linux has the tendency to have software installed that has vulnerabilities. But because Linux is open source and has a community of developers around it, the more eyes you have on something, the greater security it has. So the Linux security, or the Linux kernel itself, is pretty secure. There's always something or a vulnerability that may come out here or there, but it's patched relatively quick. In the past year, we have seen, or 2 years, depending on whenever you're viewing this, we've seen shell shock, we've seen ghost, and those have been really serious Linux vulnerabilities that we can exploit. software typically has less privileges as well within Linux. So Linux processes things with a user and a group as well. So Linux is pretty secure from the standpoint of software execution, unless you increase its privileges. The size of Linux is smaller, meaning that the community, or where Linux is installed in, is smaller. So where Windows, for example, has millions, billions of machines running Windows versions, we may see very little of those machines actually running Linux. And we don't install a lot of software on those Linux machines either, even though they are running a majority of the large enterprise systems across the internet. So how Linux may be compromised. There are 4 different areas that system administrators need to be concerned with when looking at Linux insecurity. The first one is software vulnerabilities. Second one's going to be configuration errors. Third one is social engineering users in general. And finally, the fourth one is going to be rootkits, viruses, and Trojans. So in the from greatest threat to least threat, let's go through these one by one. Software vulnerabilities. For as long as I can remember, buffer overflows are still the #1 vulnerability out there for software. Developers either forget to sanitize their code for memory leaks, and buffer overflows or buffer underruns may take place. But it's still the #1 thing that plagues everything. So the software that's installed on Linux is not infallible to exploitation of buffer overflows or buffer underruns. So the Linus law states basically, given enough eyeballs, all bugs are shallow, meaning that the more people that you have looking at code and developing that code, the less chance you have at major vulnerabilities, and those vulnerabilities becoming public. Developers of custom software may not have the luxury of testing software. So software vulnerabilities may be in some of that code that is not used by a lot of people. Software also may not be patched. Linux typically uses package managers to manage the software that's installed on them. However, if we compile Linux code or source code and put those on our systems, install the code from source, we don't get that luxury of those patches unless you recompile that software again. So it's always best to use a package manager to install certain packages, for example, like Debian packages or RPMs, for example. Configuration errors is the second most common type of threat that we see with Linux. Because we are configuring manually a lot of software on Linux, we have a tendency to make mistakes. So a directory, the permissions on that directory may be incorrect, or we may forget to delete a configuration page, which may allow an attacker in, for example. Or perhaps one of the ports that we have for a certain application is left unsecured. For example, port 3306 for MySQL. If we forget to turn that port off or put it behind the firewall, an attacker may get in. It's very easy to do something in Linux, meaning that you can type in rm-rf/*, for example, and delete everything. Linux will let you do that. It's very unforgiving that you can't undo it. Unlike Microsoft or Windows, which will not let you delete all your files. So forgetting to do something like that and not have root privileges is also one of those configuration errors that we need to watch out for. Social engineering and users are always a concern no matter what operating system that you are using, no matter if it's Mac, Windows, Sun, doesn't matter. We need to be concerned with social engineering and users because users are the weakest part of any system. Even though it's the job of the system administrator to make sure systems are secure, humans cannot be secure 100% of the time. So if a user leaks their password information out, an attacker may get into that system. This is very evident in one of the more famous cases in the hacktivist group Anonymous several years ago with the HB Gary leaks. This social engineering of the CEO was actually led to their downfall of HB Gary, and Anonymous was at the helm of that. Okay, users make mistakes. Users accidentally delete files. For example, like I said, rm-rf/star. Okay, it's a very easy command to enter. If your users have privileges to do that, then they've just destroyed a system. Amazon and other large corporations have been taken down because of configuration errors. And inadvertent commands. So several weeks ago, and depending on when you're viewing this video, maybe months, maybe a year, but Amazon, a third of Amazon was taken down, their AWS platform, because somebody accidentally entered a wrong command when configuring some software. So it took out major companies. Major companies lost millions of dollars of revenue because Amazon was down. Finally, rootkits, viruses, and Trojans. Linux is not as susceptible to rootkits, viruses, and Trojans because of the way that they're built, because of the way the privileges are designed to be least privileges. They're still better than a lot of the other operating systems out there that are less secure. Windows, for example, most Windows users have elevated privileges, for example. Okay, an example of a Linux worm would be the Morris worm back in 1988, which was one of the very first worms for Linux. Okay, Linux also has several different types of ways to mitigate that. So chrootkit, RKHunter, and ClamAV are all open source packages that are designed to keep Linux secure. So in conclusion, administrators need to be diligent about how they are addressing security, and security always needs to be a consideration. While Linux doesn't contract viruses often, we still need to be concerned with configuration errors and software vulnerabilities and make sure our systems are up to date. In this lesson, I will discuss Linux firewalls. There are several software-based firewalls within Linux. Today I'm going to discuss the Ubuntu version called UFW. I'm going to discuss the new firewall within CentOS and Red Hat type systems called Firewall D, and I'm going to show you where we came from. So let's start out with Ubuntu. The two most common software firewalls out there right now are UFW and Firewall D. Now, where we came from was what we called IP filter. IP filter is a packet filtering software that can be configured for a variety of different platforms. So we also then had IP tables, which introduced a stateful firewall rule set into Linux systems. However, IP filter is still around and can still be manipulated. It's still a loadable kernel module and can be implemented statically within the kernel. However, there have been problems with trying to configure IP filter and IP tables. They are very complicated to understand. They have many intricacies that it makes difficult for a normal user to try to configure. So the later firewall versions, UFW and Firewall D, allow us to really easily configure firewalls within our Linux systems. Firewalls are extremely important to understanding where our attacks come from and limiting those attacks. We can also log information that comes in from these attacks. So let's look at Ubuntu first. In Ubuntu, UFW stands for Uncomplicated Firewall. It is enabled and disabled by default on Ubuntu systems, but it also has packages for Debian systems and Arch. It is still a way that we can manage IP tables just with more ease. In order to get the status of what UFW is doing at the moment, we're going to type in UFW status. Status is inactive, so let's enable it. UFW enable. So now it says firewalls active and enable on system startup. So if we type in UFW status again, we'll see that it's active, and let's look at some of the rules. So UFW status verbose. Okay, logging is low, default deny, allow all outgoing, and disabled routed. So if we type in UFW show raw, we can look at the rules that it already has created. Notice this is a huge amount. Let's expand this here. Okay, let's scroll up. Notice how many rules there actually are. This is what IP table looks like if we configure this manually. It's a huge amount of rules. This is what UFW creates when we easily type in an allow or deny port or IP address. And it just keeps on going on and on. Let's say that we want to allow certain services. This is very easy to do, unlike IP tables, which is extremely complicated. We'll type in UFW, allow, 53, and we'll type in the protocol. Port 53 is DNS, so it's going to be UDP, so we're going to type in the protocol UDP. Let's say that we also want to allow SSH. UFW allow SSH. And let's say that we also want to allow communications from a different system. So let's say UFW allow from 192.168.18.131 to any port on port 22. We can also do the exact same thing for denying rules. However, instead of where we say allow, we're going to say deny. So if we wanted to deny port 80, for example, UFW deny 80. Now, let's say that we want to look at these firewall rules again. We're going to type in UFW status numbered. This shows us the status of our firewall and any rules that we have set up. If we look at the firewall rules, the raw firewall rules again for IP tables, it's going to show us a lot more rules than what we currently had. Let's say that we want to look at what we just created. UFW status numbered. Very simply, we have this information. However, let's look to see what changed in the background for IP tables. So UFW show raw, and we're going to grep for port 22. Quite a few more commands, and that's in a lot of different chains, what we call change inside of IP tables. So UFW allows us to not only add services and ports, but it looks at IP addresses as well. Now, UFW still manages IP tables. This is not the case in the new Firewall D for Red Hat type systems. So let's switch over there and let's look at Firewall D. If we type in firewall-cmd state, we'll see that it's running, just like we did on UFW. We also have the concept of zones, which is similar to chains inside IP tables. In order to look at the zones, we can type in firewall-cmd-get-zones. These are our standard zones. The only one that is actually populated, however, is public. If we want to look at services, we can look at firewall-command-get-services. There are many different type services, and let's actually list this out here. So it looks like there's 54 words overall. One line, 54 words, 471 characters. Now let's say that I wanted to add a service. In order to add a service, I'm just going to type in firewall-command-zone equals public. And let's say on this server I wanted to add a web server. --add-service equals HTTP. Success. Now within Red Hat type systems, I can still enable IP tables if I want to, if I wanted to get really, really granular with trying to put a firewall into my system. However, with the new Firewall D, there's no need, and with Firewall D, we're less prone to make mistakes. Firewalls within Linux should always be used to stop services and decrease our attack surface. In this lesson, I will discuss Linux and its services. Linux services. Linux services are usually started up on startup to run some kind of process on the system. Software or services that are not used should be disabled to decrease the attack surface of the system. As with any operating system installation, the system is already installed with general packages that may or may not be used. One example of this is Bluetooth. Do you necessarily need Bluetooth on a server?
I've never seen Bluetooth used on a server, so that is definitely one that we can disable. Let's look at Linux services. And this is my CentOS system. This is going to be different from Ubuntu and different from some of the other versions. However, mainstream in enterprises, we tend to use CentOS, as I mentioned in previous lessons. In order to see what services we have in startup, we're going to type in check config. We have net console, network, and Splunk. These are different run levels here. So we have run levels 0 through 6, and you'll notice that 0 and 1 are off, and then we have turned on for just the network portion, run levels 2 through 5. Now, I added Splunk just to show you what it would look like if that service were running on the server, but I've since turned it off. Now, if I had turned that back on, which I can do real quick, I'm going to type in check config Splunk on. Okay, and let's look at that first command again. I just type in check config, and notice that my run levels again, now they're turned on from 2 to 5. Yeah, but let's turn that off again. So check config Splunk off. And I can do this with other services as well. However, not many services come with check config turned on. In order to see what else is running in the system, by the system account, we're going to type in systemctl. Systemctl gives us what services are currently loaded and running in the kernel. So things like kernel processes. Here's one for printing down below. CUPS is a standard printing service that we may want to disable. Okay, let's look at other things. So Bluetooth, for example, we don't need Bluetooth. These are all, quite a few of these are services that need to be disabled to make sure that we decrease the attack surface of a system. So in order to do that, we're going to disable a couple services here. Notice that there's 152 processes running. So I'm going to type in systemctl and type in status. Let's look at Bluetooth. So here's our Bluetooth. Looks like it's active. And if we type in systemctl status and then the service, we can get a lot more information about what's running in the kernel. So let's turn this off. Systemctl Bluetooth. Whoops. Let's type in systemctl disable Bluetooth. Okay, now let's look to see if it's running. We're going to type in the status again. Okay. It's disabled, but it's still running. So we would have to kill that process. So what I did there is I typed in pkill Bluetooth, which means process kill, and then the process name, which is Bluetooth, and now notice that it's inactive. So it's dead. So I've just turned off Bluetooth, which is probably a good thing for my attack surface. Okay, let's briefly look at a couple more here. And we'll type in systemctl again. As we go through here, it looks like our Splunk service has failed, which is fine because I turned that off. But we can see what's active, what's running, what's inactive. Now, on some servers, especially this server is running a GUI, so I can show you what the command line looks like and some of the other processes very easily. Typically, on an enterprise server, you're not going to have a GUI. Again, it's just another way to increase the attack surface, and it also increases the amount of memory. We need to disable that. The GUI in Linux is called Xserver. So we may want to remove the X Windows system from our server. So we would type in yum group remove and then in quotes X Windows system. That'll just disable that. The other things that we should disable are things that we're not going to use. Things like IPv6. If you don't use IPv6, you should definitely turn that off. The reason why is it's, again, another attack surface. It's a big attack surface if you're not using it. One of the other functions that we're going to look at, one of the other commands, is finding permissions that may be turned on. Some processes need to run with elevated privileges. So think about how you change your password. So PASSWD, for example. I'm root here, but technically that's a root only. Process. So in order for a normal user to access or run PASSWD or some of the other functions, which we'll see here in a second, we need to turn on what we call sticky bits, and that allows the process to run as the system account or root. So what I'm going to do is I'm going to look for those processes that have sticky bits turned on for both the process running as a root or the group root. So in order to do that, I'm going to type in find and where to find it. And let's look at the permissions. So I'm going to put a / parenthesis, then the permission -perm -4000 -o -perm -2000, and then we'll print that out. Okay, so notice all these commands that have our sticky bits turned on. So SU or password, group password, SUDO. These are processes that you run all the time. And the reason why we have the sticky bit turned on is so that we can run them as root as a normal user. So you should consider disabling some of those. So in order to change or remove the sticky bits, we're going to type in chmod -s and then the file name. So if we wanted to disable locate, for example, which we're not going to do, but let's say that we wanted to do that, we're just going to type in chmod -s and then user sbin and locate. There are some other processes that you may want to consider disabling as well and have been known to be not harmful to disable to the system. And I'll post those as part of your reading for this week. In conclusion, services are a big part of any operating system. However, they increase the attack surface, so consider disabling those services that don't need to be running, such as Bluetooth or your GUI, for example, if this is a server.